So our linear approximation function is going to be a function in x and y that will give you z to approximate the actual functional value. This will be the equation of a plane with z as a function of x and y. That will be approximately what you need for minus 2x squared plus 4y squared near 5, negative 3. So that approximation won't work everywhere, just near that specific point. So let's go. How are we going to figure this out? Remember what the equation of the linear approximation is supposed to be. L of x and y is supposed to be df dx at that point, so specifically at 5, negative 3, right, times x minus 5 plus df dy at that same point times y minus 3. So this is the linear approximation part. It's the little correction that we need to still add to the function value, which is f of 5, negative 3. Okay? So this is the starting point, the f of 5, negative 3. We're near it. So any function value near that point will be close to this plus some correction, which depends on the derivative and how far along from these coordinates we're going. So let's get to calculating. Df dx is pretty simple. That is negative 4x, and we're doing x equals 5. So that's a negative 20 of df dy is 8y, and that's at y equal negative 3, so that's negative 24. So the function will definitely be going down on the positive directions. Both derivatives are negative. So last ingredient we need is f of 5 and negative 3. So that is something that's supposedly simple to calculate. So it's negative 2 times 5 squared plus 4 times negative 3 squared. So that's 25 times negative 2. It's negative 50. Plus 4 times 9, that's 36. So that would be 14 negative, I think. Check my math. As the ideas are what matter here, not the numbers themselves. So finally, the linear approximation will be L of xy. It will be a negative 20 x minus 5 plus, or negative 24 y plus 3 minus 14. That's a linear function, a lot easier to calculate than the actual value, the actual calculation that we would do to calculate f of 4.9 and f of f of 4.9 minus 3.03. Those are decimals. That'd be complicated to use. So how do we calculate them? Instead, using the linear approximation, we plug those in to get negative 20 times 4.4 minus 5 minus 24 times minus 303 plus 3 minus 14. So the idea is, of course, you can use your calculator for that. We're supposed to use either an integer or a decimal, so a calculator is fine at this point. But I will not use one just to illustrate how this is better. So minus 20, that's times a negative 0.6 minus 24 times a negative 0.03 minus 14. So what's interesting about this is that you can multiply. So first of all, the answer is going to be a positive on this first term. You're multiplying 20 by 0.06. That's the same as multiplying 0.06 by 10 and then by 2. So that's a 6 and then a 12. That's the first term. The second term again is positive. It's going to be slightly different. You can multiply 24 by 3. That's pretty simple to do as well. There'll be a 60. 20 times 3 is 60, and then times 4 times 3 is a 12, so that's a 72. But with 2 decimal places, so that's a 0.72 minus a 14. So that is a 12.72 minus 14. So pretty easy calculation there. And that's what I wanted to show, how easier that is in comparison. So that's a 28, negative 1.28, right? That's what we have. And that will be a lot easier than to actually calculate, f of 4.9, negative 3.03, which would require us to do minus 2 times 4.9 squared. Just that will be a handful by hand, right? And that would be even worse. But even though I decided not to do that, I know this number is close enough. And you could check with your calculator to understand what I'm trying to say.